So if tangent x is equal to -7, find 1 plus cosine x raised to 4 plus cosine x raised to 8 plus cosine x raised to 12 plus and so on. Before we begin, you may first try this one out on your own. Okay, good. So let's begin. So the first thing that you can do to be able to solve this problem is to observe that this sum here, which we can denote probably by S, is actually a geometric series. So that is the first observation that you need to be able to do to answer this problem. In particular, infinite geometric series. Indeed, observe that. So let's write here S. Take note that we can write this as 1 plus cosine x raised to 4. Then take note that the 8 here, cosine x raised to 8, we can write that one as cosine x raised to 4 squared. And then the same goes for cosine x raised to 12. We can write it as the following. So once we have this, notice that this one is a geometric series, since this term, to obtain the next one, we need to multiply cosine x raised to 4. To obtain this next one, we also need to multiply cosine x raised to 4. And same with this one, we need to multiply cosine x raised to 4. So in this geometric series, take note that the first term here clearly is 1. And as illustrated earlier, the common ratio here will be cosine x raised to 4. Now what's nice about this? Well, take note that if we have a geometric series, then if r here, the common ratio is less than 1, its absolute value, then this will just be a over 1 minus r. So to be able to apply that one, our goal is to establish that the common ratio here, in this case, is its absolute value will be less than 1. So that is what we will be checking out here. So let's put a checkbox out here. The question is the absolute value of cosine x raised to 4 will be less than 1. So to do this, take note that the range of cosine values, whether we raise them by 4 or whatever, can only range from -1 to 1. So just recall its graph or the unit circle. Which means that to be able to establish that this one is less than 1, all we need to do is to show that in our case, we can never be 1. So we suppose otherwise that the absolute value of cosine of x raised to 4 is equal to 1. By properties of absolute value, this can be written as the cosine x here. Then we can move the 4 outside of the absolute value. But take note that since this one is always positive, so if we get the 4th root here, what we'll get on the other side is also 1. It cannot be -1 since, again, absolute value, its range is only positive. So we can actually remove the 4 out here. And when is this true? Well, recall that in a unit circle, cosine x is equal to 1 if it is out here. But since we are considering absolute value here, we can also consider the times when cosine x is equal to -1. So we can consider it out here. And this occurs when we have integer multiples of pi. So this one is 0, this one is pi, this one can also be 2 pi, this can be 3 pi, and so on, as well as the negative side. So writing it out here, so this is true whenever our plug-in x is equal to k pi, wherein k is an integer. Okay, so I hope you were able to follow that one. But take note that if we have x to be equal to k pi, then so let us write it out here. If x is equal to k pi, then what would happen with our tangent x? Take note that if this is the case, so if we recall here, Tangent represents sine x over cosine x. We have established that for this case, the cosine x is always plus or minus 1. How about the sine? Clearly here, the sine value will be 0 since there is no y component out here. It's on the x-axis, which means that what we'll have here is 0 over plus minus 1, or in other words, the tangent x in this case is 0. And this is where the contradiction comes in, since we have established, or it is given, that tangent x is equal to negative 7. Negative 7 is clearly not equal to 0. What this means is that if this is not the case, then x cannot be equal to k pi. If x is not equal to k pi, the absolute value of cosine x is not equal to 1. And so is this one. Which means that this thing here must be satisfied. So let's put a check out here. Which means, again, if you remember earlier, if this is satisfied, then we can apply the infinite geometric series formula of like a over 1 minus r out here. So this means that, so let's put it out here, by the geometric series formula, in fact infinite geometric series, we can write our sum s. So s again here is this. We can write our sum s in terms of the first term and the common ratio. In our case, our first term is 1, and then our common ratio is cosine x raised to 4. Since we will be needing this later on, let me put a star out here, or whatever variable you want to use. Okay, good. So that finishes the first step for this solution. Once you are able to notice this is an infinite geometric series, you can obtain this sum out here. The only problem here is that we still need to obtain the value of cosine x raised to 4, and that is our next step here. So our goal now is to find the value of cosine x raised to 4. To be able to do this, the key is to recall the following identities in trigonometry. So recall that from the Pythagorean identities, the square of secant x is equal to 1 plus the square of tangent x. Aside from this, we will be needing the reciprocal identity. So that is secant x is equal to the reciprocal of cosine x. Using these two, we can now establish the value of cosine x raised to 4 in our given. So we begin with this one. Take note that we are given the value of tangent x. Tangent x is equal to negative 7. Okay, which means that we can replace the tangent x here with negative 7 squared. Simplifying, this is just equal to, so 1 plus, so negative 7 squared is 49. 1, that is 50. And then from here, we can apply the this reciprocal identity to transform secant here into cosine. So applying that identity, we'll obtain that cosine squared x must be the reciprocal of this thing here, which will be equal to 1 over 50. Since what we want is cosine x raised to 4, we just square this both sides to obtain cosine of x raised to 4 equal to square of 50 is 2,500. So we'll have here 1 over 2,500. And this is what we want in this step, right? To obtain the value of cosine x raised to 4. So let me denote it by another symbol, let's say heart. Okay, so far, we're actually almost done here. All that's left to do is to combine these two and simplify to obtain the value of the sum. So let's do that one quickly. For this final step, what we'll do is we will combine what we have obtained so far in the first and second step out here. So combining the two, we'll have here s to be equal to, so from star, we'll have here 1 over 1 minus cosine 4x. So we'll have here 1 over 1 minus cosine x raised to 4. But we have established in heart that this is equal to 1 over 2,500. So let me write it out here. What we have is a complex fraction. It depends on how you want to simplify this, but for me, the easiest way is to just multiply the denominator of the one in the complex fraction, which is this one. Its denominator is 2,500. So multiplying this, we will be able to simplify the given into and reduce it to a much more simpler fraction. So for the numerator, we'll just have 2,500. For the denominator, we'll distribute 2,500 out here to obtain 2,500 minus 1. Then just simplifying the denominator, we will obtain 2,500 over 2,499. And this is the answer that we are looking for. Yeah, so good. I hope you enjoyed that one. It's actually pretty straightforward. All you need to do is to be able to notice that this thing here is an infinite geometric series. From there, just establish this important step out here, since the formula does not hold for common ratio that are greater than or equal to 1. So if this is the case, we can obtain this. And this just using the trigonometric identities to obtain cosine x raised to 4, we'll obtain the following. Combine the two and we will be able to obtain the final answer of 2,500 over 2,499. So yeah, I hope you enjoyed that one and you learned from that one. If you have your own solutions to this, feel free to comment it down below. Besides that, have a great day.